Right, we're going back to our original query where we're looking for the employee's last name to begin with a Y. And here you can see we've done it using the where clause. But what about if we curtail this table employee? Because at the moment, this table employee has got 1,005 employees. What if we curtail the table employee so that it is only those employees whose employee last name starts with a Y, and then join these 4 employees to table transaction? And we can do that in a subquery which creates a derived table. Now this is your derived table. So this is a complete table which we are going to use in a subquery. So we're going to replace the table employee here with this. So we don't need the where clause now. So all we do is we cut our statement and we put it in brackets in the inner join. So again, because it's a subquery, what we can do is we can run it independently. We see that it creates this table. We are then joining it to table transaction on employee number, and then we order it. So let's execute that. And there are our 8 results. Now it's important that you alias the table because this derived table has no name. It doesn't know that it's a table employee as its name. You could join it with other tables. You could join it with the department table, create a really complicated subquery, but that creates a derived table. But then what's the derived table's name? And you will get a syntactical error if you don't put the as alias. You can see it's expecting as. And there are a number of instances where you will have to name the resulting table, this being just one of them. So you might be thinking, okay, is this clearer? Is this not clearer? If I put my original select query there, which is better? And the answer is whichever is better for you. But is there one that the computer is going to calculate more quickly? Is it going to find that there are only 8 rows there and it's got to do less joining with the table transaction? Well, we're going to look at something that we're going to look at in a few sessions' time called the estimated query plan. The estimated execution plan, beg pardon. Now, there's going to be a lot to this, but I'm only going to look at one particular thing. This does not give you the results. This gives you how quickly how quickly a particular query is run, where the bottlenecks are, or what we're going to look at in this case, because I've got 2 queries highlighted, what the relative speed of the 2 queries are. So I'm going to press this button, the estimated execution plan, and you can see that this first query is 50% of the totality, and the second query therefore is also 50%. And just looking at the execution plans, they look identical. So what the computer does is it looks at your query and tries to calculate the most efficient way of calculating it. So these 2, because they resolve as the same, are the same to the computer. So one isn't better than another in terms of this one will give you an advantage over that one. They're both the same. Now, if I run the queries, you'll see that they give exactly the same number of rows, 8 in each, because they are the same. Let's change it so that they're not the same. Instead of this inner join, we're going to do a left join in each. Now you might think, that this will result in identical results. But let's think about this for a moment. Let's have a look at this second query. What it's going to do is it's going to take the totality of the transactions and it's going to left join it with the table employee. So we have the totality of the table transaction and those in table employee which are the same. We're then going to limit the lot by where the employee last name starts with a Y. So we have 8 rows. It just so happens that each employee in table transaction is in table employee. This first example now, where we have this derived table, is different. What it does is it takes table employee and reduces that by those employees whose last name begins with a Y. So instead of having 1005 employees, you will limit it to 4. So we now have this derived table which just has 4 employees, 4 rows. Now the outer query takes table transaction, which just as a reminder is 2000 and something rows. There are 2486 rows. It's going to join all of those 2486 rows with the 4 rows remaining in table employee, but it's going to keep all 2486 rows of table transaction because it's a left join. And that's it. There is then no where clause on this combined table. So let's just have a look at the results. We have 2486 rows. So we have the entirety of table transaction because that's not being filtered in any way. Now, if you remember, in table transaction, in table employee, we have in both of them an employee number 123, but we have filtered out from table employee all the transactions apart from 126, 127, 128, 129. So we have the entirety of the table transaction in these first 3 columns and then nulls for everything else other than these 4 employee numbers. So 2486 rows for this way and the other way 8. There's our 8 rows. So this is really where there is an important difference between doing it as a derived table and doing it in the where clause. One final point, nothing to do with subqueries, but you can see, we will be able to see it may have something to do. What if I change this where to an and? Okay, so now let's have a look at this anew. We are joining the table transaction to the entirety of table employee. We are connecting them where the table employee is equal in both, but we're keeping all the table transaction because it's a left join, and we're joining it where employee last name starts with a Y. So what is going to happen? Well, it is actually going to result in the same thing as we have with this derived table at the top. It is going to take a table employee and it's going to limit it to where employee last name it starts with a Y, and it's also limiting it to where the employee number is in the table transaction. So let's run this and we have our 2486 rows with all of these nulls. I do not like, personally, the and being used in the join section. It looks ambiguous. I mean, it isn't. You can work it out, but there's a lot of working out. So I much prefer it being in the where or being as a derived table. But just to let you know, it is possible to use and with constants or with likes or anything like this. You could say equals 5 and it will only bring back, well, if I choose a better example, 123, because that does exist. And that will limit what we get from table employee to 123. I have to use number rather than last name, obviously. Like that. So if I run that, then we will have nulls for everything in table employee except for number 123. There it is. But I don't like it. I much prefer it if you have this in the where clause or using it as a subquery. I've just got to let you know it's possible.